Hi everyone, welcome to Science Minds. I'm your new host, Olivia Surgent. Today we're at the Purple Tree Cafe at the UC Davis Mind Institute, and we're joined by a very special guest, Dr. Ben Handen from the University of Pittsburgh. Welcome, Dr. Handen.
Well, thanks. It's a pleasure to be here.
So just to kind of begin, I'm wondering if you can tell us a little bit more, just broadly, about your research interests, the types of populations that you work with, and the types of questions that you like to ask.
Well, as you can see, I've been doing this for a while, and I've been at the University of Pittsburgh. This is my 40th year. So my research interests have generally focused on children. I'm a child clinical psychologist, so children with developmental disabilities like intellectual disability, autism, and my early part of my career I focused a lot on psychopharmacology, I was really interested in how do different drugs, particular ADHD drugs, how do they change behavior, but I've been involved in the drug trials that resulted in risperidone and Abilify becoming approved for autism. So that was something that I have done a couple decades of work on. But the last 2 decades I've been switched focus, kind of just by chance, but it's what I'm doing now and I love it. I'm working with adults with Down syndrome, so now I focus mostly on adults. And adults with Down syndrome are at greater risk for Alzheimer's as they become middle-aged, not older. And so we are kind of on the trail to figure out why, but more importantly, how to prevent it. So it's very exciting, and to me it's probably the most important work I've done in my career, which is why I'm still working.
I love it. I love it. That is amazing. I mean, just looking at your kind of background, your publications, it's so clear that you've had such a diversity of research interests and kind of this seemingly meandering journey through science.
Yes, it has. I would say meandering is a really good term.
And I mean, I think that makes sense, right? It's so rare that we see like a linear trajectory in science of like A to B to C.
Well, if you do, it's probably not really how it happened. It just looks that way in hindsight.
And so I'm wondering if you can share with us a little bit more about that scientific trajectory that you've been on, what some of your early inspiration or influences were, and then maybe some key moments along the way that caused maybe shifts in that path.
Sure. Yeah, I was talking to some other faculty and postdocs about this. And it really, I would say, my career has not been, in hindsight it looks really good, but it was not planned. And one of the advantages of being at a place like the Mind Institute and at the University of Pittsburgh is there are so many other people doing such interesting things that there are opportunities to collaborate in areas that you never would have dreamed would have been you had an opportunity to collaborate. And so my advice usually to grad students and to young faculty is, if you get invited to collaborate, always say yes. So, you know, I'll give a couple examples, and you can stop me if I'm going on beyond what you want. But so my interest in psychopharmacology, I didn't really do any psychopharmacology work as a postdoc, but when I came to Pittsburgh, I was directing a school-age clinic for kids with learning problems and developmental disabilities, and we were seeing a lot of children with ADHD and intellectual disability. And at that time, in the early middle 1980s, pediatricians were not comfortable using stimulant medications like Ritalin with kids with autism and intellectual disabilities. The lore was that it made them worse. And so this was a problem. And because that's where I was sitting, we decided we should research the topic. It wasn't because, well, I was interested, thank goodness, but this was what was coming to my clinic. And we were lucky enough, we started a study. A foundation approached us and wanted to fund this more, so we opened up a Saturday school so that we could actually bring kids in and try them on different doses of medication and observe. And that gave me the data to get what is now called a K award, and that started my interest in psychopharmacology. But as I said, I didn't wake up one day and say, this is what I want to do. It was an opportunity that presented itself. And similar to the Down syndrome, I was working on a drug trial with adults with Down syndrome, and some people in my university who are Alzheimer's experts who knew more about Alzheimer's than I did said, you know, people with Down syndrome get Alzheimer's quite frequently. We would love to scan them. Could we do that together? Yeah. And I said, sure, why not? And that's 20 years later. I'm, you know, one of the leaders of the largest longitudinal study of adults with Down syndrome looking at risk biomarkers for Alzheimer's. Again, just I said yes, and then it took off from there. So, but it looks beautiful when you look back and say, wow, what a beautiful planned life that was.
It just happened to have some good friends at the right time.
At the right time. And maybe I missed some other opportunities that would have taken me somewhere else, and we wouldn't be sitting here, or we'd be talking about something else. But that's where it's led. So.
That's amazing. I'm curious, what made you interested in getting into the field of clinical psychology to begin with? How did you land there?
Well, that also wasn't planned. I was a natural science major as an undergraduate, and I didn't know what I wanted to do as I graduated, but I found a summer job. I'm at a residential summer camp for children with intellectual disability and severe behavior problems, directed by a Harvard professor, a young guy named Bruce Baker. And I worked at that camp. That camp produced some really important researchers in ADHD. One is Bill Pelham, who passed away recently, and Steve Hinshaw, who's in San Francisco and still doing work in ADHD. So this was a camp that just trained really good people. But from there, I became a special ed teacher. So I spent 5 years in special education and thought, you know, I think I want to do something more, and psychology seemed to be the right thing to do. But I was a little lost.
But I mean, it sounds like you really found your way. How did some of those early experiences, especially as a special ed teacher, I'm wondering how they influenced your perspective when it came to working with these populations, or the research that you wanted to do?
Well, it certainly clearly made me want to focus on developmental disabilities. Yeah. So even though I went into psychology, but I wasn't planning to work with adults. I was going to stay with children. I was going to stay with kids. Well, in those days, there weren't that many kids with autism. They probably were. We just didn't diagnose them. But it certainly said this is the field that I wanted to work in. It was a group I was comfortable with and really loved working with their parents, and had worked with, done a lot of multidisciplinary work. We always had PTs and OTs and speech therapists in our classroom. So I think this just felt like I could do more as a PhD in psychology.
Yeah, from the research side. And have you seen now some of the research that you've done start to get maybe cycled back into maybe newer teachers' perspectives for how they approach the classroom, or different clinicians?
Well, I would say, I don't know if I've had too much impact on classroom interventions. Things have changed a lot in 45 years since I was a teacher. Thank goodness. First of all, I was teaching at a center. There was no inclusion back then. In fact, I think I was just telling someone that I was the teacher when 94-142 law came out. I was the teacher when the first IEPs were written. And I remember writing this IEP going, what is this? It was really kind of interesting. They weren't specific. We always had goals, but it was interesting to write an IEP. So what have I done that's had some impact? I would say that that in terms of my work in psychopharmacology, we showed that children with intellectual disability responded to stimulant drugs to treat ADHD. And I think I helped kind of revise how pediatricians did that. And I've been involved, I was part of the studies that approved 2 drugs, risperidone and Abilify, to treat kids with severe behavior disorders with autism and intellectual disability. So I feel good about that. And I would say currently with my Down syndrome work, which is not just mine, I have 94 co-investigators, so that's a lot of people. But the work that we've done is now influencing the clinical trials that are being done in Down syndrome. The measures that we developed in the last 10 years are the same measures that most the clinical trials in Down syndrome are using. And the targets that are being used, that are being selected for the drug treatment are the targets that we've been able to identify. So I feel like we've been really successful. So that's what I'm proud of. Now, we haven't prevented yet Alzheimer's, and probably in my lifetime that probably won't happen, but I think our work is going to contribute to that eventual. By the time you're middle-aged, I'm really hoping we will have a good answer for that, and for anyone with Down syndrome as well. Because luckily anything we learn in Down syndrome also can be applied to the general population. So.
Yeah, I mean, that's what I'm curious about too. You've had so much experience working with these different populations, right? Autism, ADHD, Down syndrome. Do you see any commonalities across these populations, or maybe ways to treat different co-occurring conditions that can be?
Well, it's that a Venn diagram?
Yeah.
So, I mean, up to 40% of kids with autism have ADHD, so there's clearly a lot of overlap there, and probably 20-25% of kids with Down syndrome probably have ADHD, and the autism and Down syndrome is 10 or 15%. Someone's yelling probably in the screen going, no, your statistics are wrong. But there's definitely overlap, and so I think there's a lot to be learned. I think what we apply in Down syndrome can apply in autism, and can apply for the rest of us too. So.
Yeah, so very translatable work.
Yes, I think it's translatable.
That's amazing. I'd love to talk a little bit more about this Down syndrome collective that you are a part of. Tell us, how did that get started? What are some strengths and maybe some challenges of working with, what did you say, 94?
90, last count, 94 co-investigators. Well, there's always challenges in working with 94 anybody, right? So keeping everybody organized and I'm not, the only one in charge. I share that with 3 other colleagues who know a lot more than I do. So it's great to have them. But this is it's called ABC, the Autism Biomarker Consortium -Down syndrome, and it's a non-intervention study at the moment. It's a longitudinal study following about 600 adults with Down syndrome and about 50 of their siblings. We're looking at what are called biomarkers, which look at the risk for Alzheimer's. And so we're doing neuroimaging, so we do MRIs and PET scans to look for biomarkers. We do a lot of work with blood, with plasma, looking at genetics, looking at what are called proteomics and metabolomics. It's comprehensive. We're looking at lifestyle factors, and from that parent study, there are a number of other R01s that have broken off to look at other things. So, for instance, we have a related study that's called the MOM study. Now, it's cheating because we're also looking at dads, but it sounds better to say the MOM study. So we're looking at the parents of our participants to see if there's any contribution genetically, or if they have risk factors that might contribute to their children's risk factors, which is interesting.
Yeah, adding another layer onto what I'm sure is already very complex.
Right, but I think that, as I said in answer to one of your other questions, is we're now at the point where there are now some treatment and prevention trials for Down syndrome, because adults with Down syndrome have been excluded from all the other trials that are being done in Alzheimer's in the general population. So this is for Down syndrome. And the measures that we've been using for the last 10 years, many of them are now being adopted by these trials. And we hope that many of the families, the participants that we're following, will be joining the trials. So it's a very exciting time, I think, for Alzheimer's and Down syndrome.
It sounds like it. Yeah, it sounds like you all are making some really incredible progress. Are there any even preliminary findings that have come from this, other than the development of some of these measures that are being used down the line?
Well, we've kind of been able to show what the order of biomarkers are. It's kind of called a cascade. And we know that the first biomarker that seems to start anyone, including, could be you and me, moving towards Alzheimer's, is called beta amyloid. And we can now measure beta amyloid with a blood sample. So eventually, and not necessarily because of what we've done in Down syndrome, but in the general Alzheimer's research, the day is not far where your PCP will, just like they check statins, check your HDL and LDL to see if you need to be put on a statin, they'll be checking your blood work to see if you may have some biomarkers that are suggesting that you may be developing Alzheimer's in the next 10 or 15 years, and the goal would be to be able to prevent that as well. So we know what that cascade of biomarkers is in Down syndrome, and as I'll be talking about this afternoon, it seems to move earlier in Down syndrome than in the general population, and more quickly, unfortunately. So we don't have as big a window.
Yeah. So then that early identification becomes even more important.
Right.
Right.
So for adults with Down syndrome, over half of them will have significant amyloid, this first early protein, by their early to middle 40s. So, and then that will lead to other biomarkers kind of increasing their risk for Alzheimer's. And the mean age for Alzheimer's and Down syndrome is about in their middle 50s. So, so that's young.
Substantially earlier than the general
Yeah, that's earlier than the
population.
general population. So the biomarkers come earlier, the changes come quicker, and the diagnosis comes earlier.
Sure.
And so it really does limit our window of opportunity.
Well, it sounds like you've made some incredible contributions so far in your 40 years, and hopefully we'll be able to watch you make some more in the coming.
Great.
Well, thank you so much for joining us today, Dr. Handen.
Thanks for having me.
Wonderful to chat. That's all we have for today's episode of Science Minds. Thanks so much for tuning in. We'll see you next time.
The UC Davis Mind Institute was founded in 1998 with the promise to reduce and prevent the disabilities that can be associated with autism and other neurodevelopmental conditions. Every day, our clinicians and researchers make progress on that promise. Our groundbreaking research on autism, Fragile X syndrome, chromosome 22q11.2 deletion syndrome, ADHD, and other conditions associated with disability are helping affected individuals achieve their fullest potential. Please visit our website or our social media platforms to find out more about current studies, upcoming events, and how you can help make a difference.